Welcome to the next edition of the Reimagining Mobility podcast series. I'm here with Tim Daniel. He's our MTI segment lead for ADAS. Yep. Thanks for joining me today, Tim.
Thanks for having me, Stefan.
We'll talk about ADAS today, and maybe we'll start out with ADAS 6-7 years ago maybe was identified or was associated with blind spot detection, maybe lane keep assist. I don't know. I don't exactly remember. Certainly lane keep is now a big one, right? But blind spot was a big one. Maybe forward collision warning or adaptive cruise, right?
AEB.
AB maybe as well. But tell me, what has really changed over the last 5 to 6 years that makes this area now so exciting, and especially getting into then L2, L2 plus, and L3?
Yeah. Well, one of the things that I really see is the distraction level of drivers. Even on my way to work this morning, you see people weaving around, they're on their cell phones, right? And so even 10 years ago, you look at how the use of cell phones has increased, and when ADAS was in its infancy, probably no one even realized how much that would be an issue going forward. But you know, you look at the features like AEB. It would be great to have that on every car. I know it's being voluntarily mandated by the OEMs by next year in August, and that's great. But you still have a lot of cars on the road that won't have it. And that alone will help tremendously in avoiding rear-end collisions. I know I've been in several, and a lot of them happen just from distraction. So it's great to see the inclusion of these ADAS features more universally. But I think we've got a long way to go. So just having blind spot detection or AEB and FCW is great, but we need that deployed on every vehicle. And then with the advent of like ACC and LCC, especially with distraction as well, keeping people in their lane, taking away from distractions of accelerating and decelerating on the road. I think the advent of those features will as well improve safety and counteract the distraction level that's going to happen, increasingly happen as cell phone use continues.
So you're bringing up a very interesting point. I haven't really thought about that until now, what you brought it up. Cell phone usage, right? I mean, yesterday we drove around town, my wife and I, same thing, and I'm like, every time, look, that guy or that gal, she's on the phone or he's on the phone. Sure enough, your RAV Pass has his phone, right? So now you made the point we need AEB more because it can help avoid some of the accidents. Do you think in people's mind that it means, well, I got AEB on this car, so I can be on the phone because you know what, the car will protect me if suddenly somebody in front of me brakes, or I too long looked at this text message or LinkedIn or Facebook or whatever I look at. Is there any talk in the ADAS circles on your level, with the level of expertise and experts you're talking to, about that concern as well?
Well, there is a concern that drivers will get worse.
Because we rely on technology,
exactly.
Right? Yeah.
And until you bring in autonomy like L3 and L4, SAE level 3 and SAE level 4 systems, driver skill will most likely get worse. And there will be a heavier reliance on technology. Back in the late 90s, early 2000s, when ADS was coming around, we called it Superman syndrome. People thought they were invincible. They would drive like crazy, even in snow, because they had traction control or ESP or ABS. And so you get that reliance on the technology, and then sometimes you see them in the ditch a mile up the road. So you have to be careful that you use technology in the right way to enhance safety, but it doesn't give you the excuse to, let's say, be dangerous in your driving task. So, but it most likely will. I think a lot of people don't even realize what ADAS is. They hear the name. I think they're very familiar with blind spot because it happens all the time. Auto high beam control is something that they see. They don't even know they have, and all of a sudden their high beams are coming on and off, and it's great because most of the time we don't use them because we just don't think about it. AEB, you don't experience until you absolutely need it. And so I think while some people may know on a high level that they might have this feature, but they don't really know what it is, I don't think that'll be the issue. I think it'll be the lane centering, lane keep assist, the reliance on blind spot detection that will really take people into the realm where they're like, okay, I don't have to pay attention as much because the ADAS system will protect me. So we called that the Superman syndrome.
All right, Superman. I learned something. That's perfect. That's why we're here. Today, most cars, I would say, have level 1 ADAS features. New cars coming out, not in the field necessarily, but coming out. If you were to pick 2 technologies that you're most excited about having in cars coming to production today or able on the market, what are they? And I'm not saying level 4, level 5. Let's go between level 1 and level 3. What are the 2 functions or technologies that you're mostly excited about?
Yeah. So I really like the level 2 plus systems. Level 3, we'll see how that deploys. When you take the driver out of the loop, the difference between level 2 and level 2 clearly by the SAE definition is you are driving.
Yep.
Level 3 is you are not driving.
But you have to pay attention.
On level 3, you're supposed to be in the loop when the vehicle tells you that you need to take over.
Yep.
But it's very clear by the SAE definition you are not driving.
Yep.
So the question is, do you have to pay attention because you are not driving? The vehicle is supposed to give you a certain amount of time to get situational awareness and say, okay, where am I? What's going on? And now I take over. So level 2 systems, you have to pay attention. So level 2 plus, level 2, whatever it is, you have to pay attention. Level 3, now you're getting into the realm where you don't really have to pay attention. So the difficulty is with the level 2 plus is keeping the driver in the loop where they have to pay attention, and this is why they have either hands-off detection on the steering wheel or driver attentiveness that can determine whether you're still paying attention to your driving task or the system will disable. But the level 2 plus features are really interesting, and I think that will help enhance safety because as we're talking about distraction, right? I was just thinking how many things we think about. We worry about our kids, people are on their cell phones, right? You got all these things running through your mind and somehow we can drive. But we get distracted. We have medical issues. People do things that aren't legal when they're driving, right? The level 2 plus system will never stop paying attention. And it'll tell you when it has an issue and it can't do it anymore. But when it's working properly, it's paying attention all the time. And its only job is to look at the traffic around you and make sure that you're driving in a safe way. And the reliance on the technology, people say, well, does it really work? Think about, have you ever driven to work and you get there and you're like, how did I get here?
Yeah, sometimes I do. I sometimes have like some 20, 30 seconds. I'm like, what did I just do the last 20 or 30 seconds? But I clearly paid attention, but my mind can't recollect the last 30 seconds.
But the ADAS systems, they're really getting into the AD systems, which is the level 3 and above. They never stop paying attention. And I think that the greater deployment of those as the cost of those systems comes down and the capability comes up and the deployment gets more widely, let's say, accepted by the public from a technology and a price point, that'll be really exciting.
When you're talking about technologies for, again, all the way up to level 3, we develop quite a bit of technologies at MTI, at AVL globally. What are the biggest challenges? I know we know about the testing and validation. We see that from Waymo, we see that from Cruise, we see that from Motional, all the guys that have different deployments in different cities, and they talk about millions and millions of virtual miles. So I know, or it's fairly known that is a challenge. So maybe not necessarily focus on that, but something else in the development phase, or phases obviously. What do you see the, 1, 2, 3 biggest challenges to develop the ADAS technology?
So there's a couple challenges. One is to get the sensors in the right combination at the right price point so that they can be deployed on the vehicles in a more mass scale. The other point is the computing power. If you look at a graphics-based system, the power consumption is very high, and you've got a lot of heat challenges. If you look at a neural net type of processing platform, there's a lot of learning that you have to do, but the power consumption is less. There's a lot of exciting technology coming out on both fronts that will help with that kind of centralized computing, platform with, let's say, non-smart sensors, so they're just sensing and sending the data to a central compute platform. That gives the OEMs a lot of flexibility in how they deploy their driving features, because now you've got the features contained in one place instead of distributed amongst different sensors around the vehicle. But the advent of 3D or imaging radar is going to be great. Gives you elevation measurements as well as really detailed, very detailed definition of the environment. If you've ever had an experience with ACC on the road where you go under a bridge and the system slows down, the elevation measurements on radar haven't been traditionally very good, so it can't really distinguish between a bridge and something that's in front of you on the road surface. So the imaging radars will be great. The advent of cost-effective LiDAR. So now you have, between camera, radar, and LiDAR, a sensor suite that can handle almost every environmental condition. And to get those sensors in a cost-effective way and get them deployed on the, let's say, the more mass-produced systems, I think is one of the challenges in the industry. Right? There's a huge cost pressure on components to get them down so that they can be implemented. And then, of course, you mentioned the validation part, and that is always challenging, not just from a technical point of view, but to do it cost effectively. So a very famous person at Tesla many, many years ago made the statement, LiDAR is not necessary. Even recently they made the statement, we don't even need radar, right? What is your opinion? And again, I'll keep it in up to level 3, not level 4, level 5, which I consider ADAS, autonomous driving. Do we or do we not need LiDAR to do level 3? I think there's...
Or should we or should we not? I mean, I guess there are companies that do it, that don't use it. There's companies that use it. But in your opinion, is it needed, or is the ones that are using it maybe more using it for, I want to test it, get more familiar, so then once we deploy those vehicles in level 4, we're much more comfortable with LiDAR, but we don't really need it for level 3? Or are you saying, no, I believe we do need it for even level 2 plus maybe?
So there's always advantages and disadvantages for each sensor. And I would say if you're invested in one technology, if you're a surgeon and you have a knife, all you want to do is cut, right? So if you're invested in camera technology and making that the best you can, then of course you're going to say you can do it with camera only. But there's advantages and disadvantages to each sensor. For instance, cameras don't see well at night, right? They'll see the headlights, but to differentiate. So if you're looking at camera, what do you really mean by camera? You could be looking at camera, but also infrared, because now you can see, pedestrians very clearly at night because we give off heat and we're different than the environment around us. So there's that differentiation on the camera side. With radar, you get direct velocity measurement as well through Doppler, and it's not as reliant on you're not reliant on light. It can see through fog better. So there's advantages there. LiDAR gives you very, very precise distance measurements. So as you get into the higher speeds and the more complicated type of scenarios, LiDAR has that advantage of very, very precise distance measurement. So I think in the end, when you get to the L2 plus systems and you get to the L3, where really you're taking on the driving task in a much varied environment, LiDAR will be very much a part of the sensor suite because of that very accurate distance measurement.
We talk for a moment now level 4, level 5. We've seen a lot of activities by the passenger OEMs over the years that I have seen dying down over the last 2 to 3 years, while at the same time on heavy-duty trucks, for obvious reasons, shortages of drivers and all that, and the movements of goods mainly, and the increased movements of goods nowadays. How soon do you see level 4 and level 5 really deployed on a, I would say, large scale, or at least level 4? Let's leave level 5 out. I think that's still years and years out. But level 4 for deliveries between, let's say, even Chicago and Detroit, between major distribution centers. When do you see that for heavy-duty trucks?
So just to look at the difference between level 4 and level 5, they're really the same technology. It's just level 4 limits where it operates, right, and under what conditions. So I think the reason you're seeing the push on the level 4 and level 5 for trucks is because of the challenges in the freight industry. It's not a very exciting job. You're out on the open road. So I think there's a lot of opportunity for autonomy to complement the existing drivers and freight companies to balance out and take those, let's say, boring on-road routes that maybe a human doesn't want to do, right? Yeah. You're away from your family, for instance, for long periods of time, so there's a lot of advantages there. I think when you talk about an 85,000-pound truck barreling down the highway at 70 miles an hour, there's challenges there, right? The stopping distances for trucks are greater. The maneuverability isn't as good as like a sports car, right?
Especially with us crazy drivers driving around them,
people cutting trucks off and things like that. So it's not a technology that's for the faint of heart, and it's not easy. And while I know that there's some pushes to get the technology out by around the 2025 calendar year timeframe, I think we have to be cautious with it. I know there's been some demonstrations of it working on the road, and that's great, but these are roads that are, let's say, have very less challenging weather, not as heavy density of traffic. So it's great, and it's a huge achievement. But to deploy it in mass scale, where you're going to have differing weather conditions, snow, for instance, right? Can you see the road?
Not intersections, but highway changes. Right? That's why I use Detroit to Chicago, because there's a long time you drive on the same highway, but you still, if you go from Detroit, there's still many times you have to switch, right? Or toll booths, maybe even around Chicago. That's what I'm saying. I think. What are you saying? Are you saying 2030? Are you saying 2035?
I think you'll see some deployments in the 26, 27 time frame. But again, it'll be limited. Crawl before you walk before you run. There is a liability aspect. You want to gain experience in the let's say the less complex environments, so that you can learn from those without putting anyone in danger, right? You've got an expensive truck, you've got people on the road, you don't want to have either of them damaged in any way, right? So I think you'll start to see some systems in the 26, 27 timeframe. Wide adoption, I think, will be longer. One of the things I haven't heard a lot about, and I know there's some of the OEMs who have addressed this, but when you get a bug in your system, and I mean literally, right? I know if you drive along the highway in Ohio and you hit the fish fly season, it can blind your sensors. Well, it's difficult for a human driver. Now you've got to have a autonomous vehicle say, okay, what do? I have to pull off, because even some of those can't be cleaned off. So all of those challenges have to be addressed before you can have widespread adoption.
All the corner cases, as we call them,
Well, bugs hitting your sensors is not really a corner case, right? I mean, it happens almost every day, so that's a key point that has to be addressed.
But the fact then again is, how do you address then the vehicle driving, right? How does the vehicle detect, oh, my sensor is now too much covered, right? How do we detect, oh, our windshield now is too dirty, now I need to turn on the windshield wiper?
And that's again why you need different technologies, so you can compare them against each other. It's just like looking at diagnosing of temperature sensors in the vehicle. If the vehicle's been sitting, you can take the temperature of all the sensors, and they should be within a standard range of each other. Same thing you can do with the sensors. Is the radar seeing the same as the LiDAR as the camera? And therefore you can tell if one technology's been degraded or not. And the one thing we can't rule out is GNSS and IMU data with high definition maps. And can you do a limited risk maneuver with limited sensing capability with really good maps and good geolocation data? And all those technologies combined give us a whole lot more information than what we take in when we're driving, because we tend to focus on just what's in front of us. And as I said before, it's amazing we do what we do. The other thing with commercial vehicles is bringing sound into effect. is if you can diagnose sound, you can even diagnose issues before they become a mechanical failure. Or how do you sense a flat tire? All of those things. Vibration comes into effect. So when you're looking at a commercial vehicle, you have to take sound, vibration, all your sensing suite, GNSS and IMU with geolocation data. You bring all those together, and you've got a really powerful navigation suite.
Okay. Maybe last question. When you look at all the technologies that we're bringing out, all these technologies, starting with software, the sensors, how we integrated, the systems engineering, the validation, the simulation tools, the virtual tools, all of those things. What do you see as the two main challenges when developing a level 3, let's say again, go level 3 or level 4, a level 3 vehicle? What are the biggest challenges you see? So, maybe again, I'm saying you can say, yeah, I think we're pretty good with AI. I think we're pretty good with the compute platform, at least for level 3s. But we're really still, what I still see struggling, the OEMs or our customers or we as an industry, not really considering might be cybersecurity or a really thorough review of the system architecture and the system behavior, the fail-safe behavior. I'm looking for those sorts of things. Maybe the top 2 or 3 in your mind.
So the one thing that I hear people have challenges with is how do you get your scenarios to do your testing with, whether it be in the virtual domain or in the real domain. And we have an approach.
Scenarios like the fish fly, for example.
Yeah. And even just the very geometries that you get on the roads. If you're on the highway, there's design standards that you have to meet to be an interstate. That's not true on surface streets. They can come in every shape and form and speed and geometry. So we have a way of generating those scenarios so that you can get the hundreds of thousands, millions of different scenarios run through those in the virtual domain. And so we have a solution to bring those varied scenarios to bear. The second is how do you link all those test results back to your requirements? We've come up with different methods to do that, but I think that's a huge challenge because the more you test, now those tests have to be meaningful. So you have to have good reporting and dashboarding to get meaningful results out of those tests, which we have tools and techniques to do, and then also link them back into your requirements so that you can prove that your system actually has been tested and validated to its intended performance. I think one of the things that will be challenging is to adopt all of technology into a right-sized compute platform. I think the hardware and the chips that are coming out today have significantly greater power, and that's great. The right balance will be how much computing power do I need to execute the driving task safely, and how do I do it in a cost-effective way and use of resources, as I was saying, for heat, right? If you have a really high-power system, you might have to look at water cooling, right? And that adds cost to the vehicle as well. So there's lots of technological challenges in the compute platform space as well.
Last question for you. I'm going to put you a little bit on the spot, maybe. What's more important, the software or the sensor?
So that's a good question, and I would say it's the software. And the reason why I say that is in my past experience working on radar, there's some companies that have really excellent front ends in terms of the radar side, the antenna design, the chirp design,
the RF,
the RF side of things. And they have really lousy software, and they have a poorly performing or even a mid-range software, so they have a poor mid-range performance or maybe they balance their RF side with a mid-range software and have a good sensor. And then there were suppliers out there that had really lousy RF but awesome software, and they had a really well-performing sensor. So the software guys will love this, but you can balance deficiencies in the hardware with really good software. So I think it'll always be where you come up with really innovative and great solutions on the software side. Okay.
So maybe another reason then why everybody talks about software-defined vehicles.
Yeah, absolutely.
All right, very good. Yeah. Thank you, Tim.
You're welcome. Thank you.
For your insight here, very, very valuable and interesting. And thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.